Right now, as you are reading these words, nearly 44 million people across the western and northern United States remain under a heat advisory, or an extreme heat warning. Salt Lake City, Utah recorded a new all-time high on July 12th, reaching 109 degrees Fahrenheit. The National Weather Service and ABC News stated the 111 degree Fahrenheit measurement in Billings, Montana, on July 12, 2026 was an all-time heat record. At the exact same time in Colorado, firefighters are still battling a wildfire that has already destroyed more than 850 structures, one that ignited during the same stretch of heat and dry lightning that has been baking the region for weeks. And in Missouri, rescue crews spent last weekend pulling hundreds of people out of floodwaters in the same general stretch of the country that had just spent days under a punishing heat dome. A woman was found dead in a creek near her home after floodwaters swept through. None of these three things, the heat, the fire, and the flood, are separate stories. They are the same story. And that is exactly the point scientists have been trying to communicate all summer, while the news cycle treats each episode as if it arrived from nowhere. The heat itself is rarely the most dangerous part of a heat dome. What comes after it, the dry lightning it sparks, the baked ground it leaves behind, and the flash floods that baked ground can no longer absorb, is very often worse. This is the story of what actually happens after a heat dome breaks, explained the way the scientists who study this pattern actually explain it. Let's get into it. To understand why the aftermath of a heat dome can be more dangerous than the heat dome itself, you first have to understand what extreme heat actually does to the ground underneath it. Because this is the part almost nobody explains, and it changes everything about what happens next. When soil bakes under high pressure and intense sun for days or weeks, it does not simply dry out the way a sponge left in the sun dries out. In many cases, especially where vegetation has already been stressed or killed off, the surface layer of soil can develop what scientists call a hydrophobic crust, a water-repellent layer that behaves almost like pavement rather than dirt. To understand hydroclimate whiplash, it helps to imagine the atmosphere as a giant sponge that will absorb water until it reaches its limit, then wring it out, dropping water to Earth's surface. When that sponge releases over a surface that has been baked into near impermeability, the result is not relief. It is disaster expressed as runoff. One researcher from the University of Reading demonstrated this effect using something as simple as a bucket of water poured onto dry, sun-baked grass, showing how a surface that should absorb rainfall instead lets it run straight off, exactly the way water runs off a driveway. Heavy rain falling onto ground baked hard by a heat dome has nowhere to go but sideways, gathering speed and volume as it moves, rather than soaking in where it lands. This is precisely the mechanism that turned the collapse of this summer's first heat dome into a genuine flooding emergency. On Friday, a flash flood emergency was issued across Iron and Reynolds counties in Missouri, where rain totals reached as high as 25 inches. More than 351 rescues were performed as of Friday evening. Of those rescues, 200 children from Camp Tom Sauk were relocated to St. Louis. Search operations continued along the Black River in Missouri this week, after a 1-in-1,000-year rainfall event caused catastrophic flash flooding, washed out roads and campgrounds, and prompted hundreds of rescues. The National Weather Service issued a rare flash flood emergency on Friday, July 10th for parts of Iron and Reynolds counties, urging residents to move to higher ground immediately as thunderstorms unleashed torrential rainfall across south-central Missouri. Floodwater rose so rapidly that the Missouri National Guard used 8 UH-60 Black Hawk helicopters to evacuate 202 children and counselors stranded by floodwaters at Camp Tom Sauk in Lesterville. A 1-in-1,000-year rainfall event, not a 1-in-50-year event, not a 1-in-100-year event. The most statistically extreme category of precipitation the atmosphere can produce, falling onto ground that had spent the preceding weeks baking under a heat dome with very little rain. The floodwaters of the Black River were seen in Lesterville, Missouri on July 10th, 2026. The governor of Missouri declared a state of emergency on Friday in response to flash flooding. With additional heavy rain expected through the weekend, the threat is not over. If you're camping, floating, or spending time near rivers and streams, move to higher ground and stay alert of weather conditions, said Governor Mike Kehoe. The storms that broke the first heat dome of this summer ultimately knocked out power to more than one. 3 million homes and businesses, and killed multiple people on top of the roughly 25 deaths the heat itself had already caused in the preceding days. The full toll of a single heat dome episode, once its collapse was counted alongside its peak, was dramatically larger than the temperature record headlines suggested. Now let's talk about the second mechanism, and this one is even less intuitive because it involves the atmosphere producing lightning without producing the rain that is supposed to accompany it. During a heat dome, the atmosphere becomes what meteorologists describe as hot and unstable. Conditions that are favorable for thunderstorm development even while overall humidity stays low. When those storms form, the rain falling from them can actually evaporate before it ever reaches the ground, a phenomenon known as dry lightning. The lightning itself still reaches the surface, even though the moisture that should extinguish anything it ignites never does. AccuWeather forecasters noted that initially little rain may fall with the storms, and the risk of lightning-induced wildfires may increase along with large dust storms or hay boobs. As the monsoon develops and expands northward, the dry lightning and wildfire danger and accompanying heat surge will tend to push farther to the north and the west and into part of southwestern Canada. Heat waves also strip away overnight humidity, meaning fires that do ignite can keep burning actively through the night instead of calming down the way fires normally do once the sun goes down. And the dead, dried-out vegetation a heat dome leaves behind keeps that elevated fire risk alive for days or weeks after the temperatures themselves have already returned to normal. In Colorado, the Aspen Acres fire has nearly doubled to 99,077 acres. With 36% contained, has destroyed at least 193 homes around Beulah and still threatens the town of Rye. The state's major fires total more than 200,000 acres combined. Smoke from Canadian wildfires is degrading air quality across the upper Midwest and Northeast, more than 200,000 acres combined, across multiple fires all burning simultaneously, all of them connected to the same atmospheric pattern that produced the heat records in Salt Lake City and Billings. There is a third mechanism, and it is the one that connects fire and flood together into a single continuous hazard rather than two separate events. Once a wildfire burns through an area, it leaves behind more than ash. Intense heat from a fire can bake the top layer of soil into the same kind of water-repellent crust a heat dome produces on its own, except more severe. Because burning vegetation releases waxy compounds that seep into the soil and seal it even more tightly against water penetration. The global consequences of hydroclimate whiplash include not only droughts and floods, but the heightened danger of whipsawing between the two, including the bloom and burn cycle of overwatered, then overdried brush, and landslides on oversaturated hillsides where recent fires removed plants with roots that knit the soil and slurp up rainfall. Scientists who study this effect in places like British Columbia, where wildfire seasons are frequently followed within months by catastrophic flooding, describe the resulting landscape as primed for disaster. Burned hillsides with no vegetation left to slow water down, sitting on top of soil that can no longer absorb it, turn even moderate rainfall into fast-moving floods, and debris flows capable of sweeping away roads, homes, and people. This is why researchers increasingly describe droughts, heat waves, wildfires, and floods not as four separate weather stories, but as a single connected chain. Scientists have started calling this compounding pattern hydroclimate whiplash. Anthropogenic climate change is not only the culprit behind the accelerating whiplash, but a key driver of the expanding atmospheric sponge, the growing ability of the atmosphere to evaporate, absorb, and release 7% more water for every degree Celsius the planet warms. The problem is that the sponge grows exponentially, like compound interest in a bank. As with hydroclimate whiplash, the rate of expansion increases with each fraction of a degree of warming. This mechanism can be described by a thermodynamic principle known as the Clausius-Clapeyron relationship, which basically says that as atmospheric temperature increases, the amount of water vapor the atmosphere can hold also increases. For weeks now, a massive heat dome has been sitting over large parts of the country. And while it baked the surface, it was also loading the atmosphere above it with an enormous reservoir of water vapor that had nowhere to go while the dome's high pressure kept lids on any rising air. When that dome finally breaks down, that stored moisture does not simply drift away quietly. It gets released, often violently, as cooler air punches in from the north and forces all that trapped water vapor upward at once. 2 major heat domes in the span of 3 weeks is not normal, even by the standards of a warming planet. The 2026 North American heat wave, which climate scientists are already treating as a signature event, has now touched more than 200 million Americans across multiple episodes. The structural question is whether American infrastructure, from aging power grids to underfunded emergency services, can absorb what is becoming a bi-weekly cycle of extreme heat events. The July 4th dome already exposed how thin the margins are in the Northeast. The Western Dome is testing the same margins in communities that are simultaneously fighting active wildfires. The honest answer to that structural question is that the margins are getting thinner with each successive event. The rescue crews that spent last weekend pulling people out of Missouri floodwaters need time to recover before the next round. The firefighters battling Colorado's fires are the same ones who will be stretched thin if the heat dome produces new ignitions in new regions. And the utilities that spent the peak of the heat dome managing record electricity demand from air conditioning only have days before they face a completely different kind of grid stress. Downed power lines and flooded substations from the same storms that broke the heat. Same crews, 2 different categories of emergency, back to back, with little recovery time between. Now here's what the data says about how much worse the after effects of a heat dome can actually be. Not rounded up for effect. the actual numbers. Heat alone kills more Americans in a typical year than floods, hurricane-force winds, and tornadoes combined, making it the most underestimated killer in American weather. But when a heat dome's aftermath compounds into flash flooding, as it did over the July 4th weekend this year, the death toll accelerates rather than resetting to zero once the heat itself breaks. The full toll of a single heat dome episode, once its collapse, not just its peak, was counted, was nearly 30 deaths. And wildfire destruction adds a separate, slower-moving toll on top of that. More than 200,000 acres burned, hundreds of structures destroyed. The aftermath of the July 4th heat wave sparked an urgent conversation regarding urban planning and public health infrastructure. Experts argue that current cooling strategies are insufficient for the projected temperature increases of the coming decades. Proposed solutions include the expansion of urban green spaces, the implementation of cool roofs, and the creation of more accessible government-funded cooling centers that remain operational during power outages. There's also a slower, quieter version of the same compounding pattern that rarely makes headlines at all. It plays out in agriculture and water supply rather than in a single dramatic flood or fire. Extended heat domes accelerate evaporation from reservoirs, irrigation canals, and topsoil alike, meaning a region can exit a heat dome technically still within its seasonal rainfall average on paper, while functionally deeper into drought than those numbers suggest. Because so much of whatever moisture did fall during or after the heat evaporated again almost immediately in the heat that followed. Farmers dealing with crops already stressed by weeks of extreme heat then face a genuinely difficult choice when the rain scientists have been warning about finally arrives. Because a hard, sudden downpour on baked, compacted soil is far less useful to a stressed crop than the same total rainfall spread gently over several days, since so much of it runs off, rather than soaking down to the root zone where it is actually needed. Since the start of July, multiple deadly flash flood events have occurred in the U.S., reflecting the increasing intensity of flooding events that is, unfortunately, our new normal. Severe to exceptional drought conditions across south-central Texas had already left soil across the region unable to absorb rainfall efficiently well before the flash flooding of this month struck. Many factors led to the tragic flooding in Texas earlier this month. One of them is hydroclimate whiplash, a period of extremely dry followed by excessively wet conditions. These conditions were seen in Texas and contributed to the severity of the recent flash flooding. The same underlying physics explains why flood watches and extreme heat warnings have repeatedly been posted for overlapping parts of the country on the exact same day this summer, a combination that used to be considered unusual and is increasingly becoming the default pattern for how a heat dome actually ends. The climate whiplash, the intensifying, growing ability of the atmosphere to evaporate, absorb, and release moisture in increasingly extreme events, every fraction of a degree of warming speeds the growing destructive power of the transitions. As this newest heat wave that shattered all-time records in Salt Lake City and Billings now begins its transition, with forecasters warning that relief, when it finally comes, will very likely arrive the same way relief has arrived every other time this summer. As a sharp transition capable of producing its own separate hazards, the North American monsoon continues generating thunderstorms across southern Arizona and New Mexico. Storms forecasters have specifically flagged as carrying elevated flash flood risk in burn scar areas and slot canyons, the exact terrain where earlier fires have already primed the ground to fail against incoming rain. Emergency managers who have watched the same sequence repeat itself in region after region this year have started pushing for something specific in response, treating the days immediately following a heat dome's collapse as their own distinct alert category rather than simply an afterthought once the heat advisory expires. Several of the flood watches issued across the Ohio Valley in the South this month were explicitly framed around the preceding weeks of heat and drought rather than purely on forecast rainfall totals alone. A shift in how warnings are communicated that reflects growing recognition, even within the National Weather Service itself, that the danger window does not close the moment the thermometer drops. The honest, grounded summary of everything we have just walked through is this. The extreme heat gripping large parts of North America this summer has never been a single isolated hazard. And treating it that way is exactly what leaves people unprepared for what typically follows. Heat domes bake soil into a water-repellent crust that cannot absorb rain efficiently. They create hot, unstable atmospheric conditions capable of producing dry lightning that ignites wildfires even without matching rainfall. And the fires and drought that heat leaves behind further harden the ground beneath them, setting up the flash floods and debris flows that so often follow within days or weeks. This summer has already lived out that exact sequence, completely and more than once. A heat dome through the end of June and the 4th of July that killed roughly 25 people through heat alone, followed immediately by storms that killed more and cut power to over 1 million homes, followed by a second heat dome that coincided with Colorado's fires, destroying hundreds of structures, and the catastrophic Missouri flooding that required 202 children to be evacuated by military helicopter in the middle of the night. And, as the third heat dome of this summer now peaks across the northern plains, The same forecasters warning about ongoing extreme heat are simultaneously warning about flash flood risk in the exact burn scars and canyons that earlier fires this year have already left exposed. The practical lesson scientists want people to take from all of this is not that heat domes are becoming more frequent, though they are. It is that the moment a heat dome finally breaks is not the moment to relax. Treating a flash flood warning issued the week after a heat dome with the same seriousness as the heat advisory that preceded it. Avoiding burn scars and canyon terrain during and immediately after monsoon thunderstorms. Understanding that a hardened, drought-stricken landscape can turn a normal rainstorm into a flash flood. These are not abstract climate talking points. They are the specific pieces of situational awareness that directly address the actual mechanism behind a risk that has now killed people in multiple states across 2 separate episodes of the same pattern in a single month. The collapse of the current heat dome is very unlikely to be quiet. It never is anymore. And behind every number in this story is a family in Elvins watching floodwater climb their front steps, a counselor at Camp Tomsock waking 202 children in the middle of the night to get them somewhere safe, and a rescue crew in Iron County that worked through darkness and rising water 351 times before the sun came up. The heat records made the headlines. What came after them is still making its way through the river systems and the burn scars and the saturated emergency response systems of a country that keeps treating each phase of this pattern as if it arrived unexpectedly. It did not. The scientists have been mapping this chain all summer. The question is whether anyone is listening before the next warning goes out.